is this biomarker approach. And this is what I'm going to spend some time on. The biomarker approach, the basic idea is to do one cross-sectional survey and then to develop laboratory assays that try to distinguish new infections, people who were just infected fairly recently. And so the approach requires only one snapshot or cross-sectional sample, and then to give people this a laboratory assay to see if we can figure out who was infected recently to somehow get an HIV incidence rate. So the biomarker approach for estimating current HIV incidence. So basically, you have two assays. Let's call the assay 1 the blue assay and assay 2 the yellow assay. And the first assay becomes positive very shortly after infection. The second assay doesn't turn positive until some time period after infection. So if you are positive on the blue assay and negative on the yellow assay, we say that you're in the window period of infection. Now, the window period of infection is not a fixed number, but it's a random variable. So S of T is the survival distribution, say, of these window periods, and it has a certain mean window period, mu. So mu is the mean of that white period of those window periods. So the basic idea of the theory then is that the probability of being in the window period, if you're given these assays, is the risk of having been infected T days ago and then having a window period greater than T. And if we'll assume G, that the risk of being infected is approximately constant over the support of the window period distribution, so I'll take that out. And that seems reasonable if these window periods are on the order of several months, which they are. Then you get G and you get this integral, which is just the mean duration of the window period. And so basically, all that is coming out here is that the proportion who are in the window is the incidence times the mean duration. So prevalence equals incidence times the mean duration at E101. That's all that's going on here. So how do you use this biomarker approach? Well, you do a snapshot cross-sectional sample. You look to see how many are in the window period using these laboratory assays. The proportion in the window is the incidence times mean duration. You solve for the term in yellow using the terms in blue. So it's the number in the window over the number who are negative or in the window divided by the mean duration of the window period. It's a cross-sectional sample approach. No follow-up is needed. That's the big message. No follow-up is needed. You don't need to longitudinally follow people. So it's called a snapshot estimator. So what kind of assays are being used for this? Originally, it started to be used with an antigen assay. But the mean duration of that window period was very short, 28 days. And so the statistical precision was very imprecise because there weren't very many people being caught in the window. The big advance was when some other antibody-based assays were developed, like the tuned assay. Basically what they did was they took the standard ELISA test and weakened it. I've never seen an example where you actually want to weaken an assay, make it less sensitive. But this is one, so that the second assay became positive later. So it was weakened so you could capture people in the window period, except positive on the more sensitive assay, but negative on the less sensitive ELISA assay. That gave a window of about 120 days. And then the BED assay, also an antibody-based assay, looking at the proportion of IgG directed against HIV. And the advance with this assay was not as sensitive to the strain of HIV. And it gave a mean window period of 156 days. And some new other assays, one called an avidity assay, which has to do with the maturity of the HIV antibody response, which is a new direction as well. So, for example, how do you calculate this biomarker? Here, estimate, suppose you have 1,700 people in your single survey. You test them for HIV, 1,200 are negative, 500 are positive. You take 500 who are positive and test them with this new BED assay. And let's say you found 19 were in the window period. So, therefore, HIV incidence rate would be, you take the 19 out of the 1,219, and you divide by the mean window of the BED assay, which say was 156 days, which gives you an answer of 3.6% per year is the annual rate of infection. And in fact, this is how the CDC is estimating obtaining their current estimates of HIV incidence. They estimated that about 56,000 annual new infections have occurred in the United States in their JAMA paper, and that was based on this biomarker approach. There were complications here because it was not a random sample of people who were being tested with the biomarker. They had to estimate a probability of people coming in to get their HIV test, and the data was based on only 19 surveillance areas and had to be extrapolated to all 50 states. So there were complications, but basically that was the heart of the idea. And in fact, this biomarker approach is now being used in a lot of countries successfully. But it's not without controversy. CDC says the BED biomarker assay is the preferred approach for calculating HIV incidence in the United States. UNAIDS disagrees. UNAIDS does not recommend the BED assay for determining incidence. So why is UNAIDS saying not recommending it? Well, it turns out there have been some studies, particularly in Africa, which have shown that the biomarker approach overestimates incidence from what you would get in a cohort study. In particular, one study in Zimbabwe, it was a study of new mothers who were given the biomarker approach to estimate HIV incidence, and then these new mothers who had just delivered birth were followed in a cohort fashion to estimate incidence. It was found that the biomarker approach that I just outlined for you gave an estimated incidence that was 2 times higher than the cohort approach. So the problem is, which is right here? And there are uncertainties, actually, with both methodologies. With the cohort approach, there are issues of follow-up bias, as women or people in the cohort who stay for follow-up, people may be selectively dropping out. There's also behavior change and counseling going on as people are longitudinally being followed and coming up for follow-up visits, changing the underlying incidence rate. There are also problems with the biomarker approach. Uncertainties in the mean window period, mu. And then there is this issue of false positives. People who show up in the window period, but they're long-standing infections. They've been infected for a long time. And that's led to a number of statistical adjustment procedures, in particular papers by Hargrove and McDougall, as well as a lively discussion in the scientific literature about when and if such adjustments are appropriate and how they should be done, including a paper I wrote, and also a paper that Steve Lagakos that was actually just published this past month. But I think to really to get to the bottom of this and to understand some of this discordance, I'm going to have to take a statistical detour for a minute and try to get a little more insight into what's going on here. So I have to actually go back to the theory for a moment and go back to something I sort of rushed by for a moment, which was that assumption that HIV incidence, remember I came out prevalence is incidence times mean duration, I said incidence was constant. Let's go back to that for a minute.
What about if incidence is not constant over time, not